Before we go over any problems involving R, I just want to quickly go over some of the basics of R. So we'll kind of go over a lot of this in the next video too when you we'll look at how to do a practice problem. So we'll go over it more in context in that video. A lot of the same stuff, but I just want to look really quick at some of the basics just by themselves first. So again, this is RStudio. So here's our current R version right on the top left here. So you want to make sure that's up to date. I have 4.5 right now. In the top right, this is a list of this is keeping track of all of the variables you currently have stored. So I don't really clear this out a lot. So I have a lot of them saved in here. So let me just go ahead and clear this out. So you just do that by pressing the broom key. So you probably don't have anything in there yet, but if you do, you could do the same thing. In the bottom right, here we have the help window, and we'll look at some of that as we go. And then on the left side here is the console. Now you might have another window that looks like this, which you usually will. So this is an R script file that I just pulled up here. So this is where you can kind of type your code without actually running it. So if I'm just going to write like x equals 5, for example. When I press enter here, it doesn't actually run the code unless I just press run. Okay, so that's the difference with, if you do something down in the console, as soon as you press enter, it's going to actually run that code. So you can see on the top right, the x variable changed to 7 from 5, right? So we typically will work in the script file first, write out all of our code, and then once we're happy with it, we can go ahead and run it. And then that makes it a little bit easier to edit it as we go too, because oftentimes you're going to not write it perfectly right away, right? You're going to keep going back and editing it. So some people like to just keep it in a separate notepad file. I had an instructor that did that. They didn't even really work in RStudio. They just worked in the R console by itself, and they used a notepad file to keep track of the code. And that's of course fine, but this kind of just keeps it all in one program. So let's just look at some basics here. So, at the end of the day, this is kind of just like a giant calculator that's just a lot more sophisticated, right? So we can do the normal calculator operations. 2 plus 4, it's going to give us 6. 8 times 9, we're going to get 72, right? 80 divided by 8, we're going to get 10. 80 minus 7, we're going to get 73, right? So you got your basic arithmetic operations. That's all fine. So most calculations you'll need to do that you would normally do in a calculator, you can probably do it in R as long as you know the correct function and you type everything in properly. Okay. So speaking of functions, so this is what we would call a function. So I already have the help window pulled up for this one. So let's just use median here. So we have a function and then we put stuff inside of the function. The stuff we put inside of the function we call arguments. Okay. So if we look on the help window on the bottom right corner over here, we can see that the median function can take several arguments, and the arguments are going to be separated by commas. It only needs one argument, which is x. So, and this tells us right here about the arguments. So x is an object for which a method has been defined, or a numeric vector containing the value whose median is to be computed. Okay, so this could just be a single number. The median of a single number is just going to be that number, of course. If we want to put in a numeric vector, as it says here, so we can define, right now x is defined as 7, so if we do median of x, we're just going to get 7, of course. But if we define x differently, so the way we can define a numeric vector is by just setting it equal to something, and we use this other function called just c. So I'll go back to that in a second, but this just lets us list out all of the numbers we want to use. So let's do 1, 2, 3, 4, 5. So now you can see on the top right, x is the vector with the values 1, 2, 3, 4, 5. So now if we take the median, we should expect the median of x to be 3, right? And it is. Okay. So you can see the other arguments that you could have a median, na.rm. This is a common one. So this is a logical value indicating whether na values should be stripped before the computation proceeds. Okay. Logical value typically means that it's going to take either true or false. So right now, this is telling you what the defaults are. So if you don't type anything, this is what it's going to do. Right now, na.rm is equal to false. So it's not going to strip any NAs out. And NA is going to come up whenever you put in something that's, not a number. So if we do median of, say, A, well, that's just going to give us an error, right? If we do median of NA is actually like a stored number, quote unquote, in R that just indicates that it's, something that's not a number. So that's going to give us NA. So this will come up in if you're working with like a data set and you have a bunch of, say values in a column and you want to take the median of that column, then you might take the median and it gives you NA. And then you're wondering why. Well, maybe you go back and look and there's like a typo in one of them and it actually, or maybe it's even if it's just blank, maybe, then R will automatically take it as an NA, right? So even just having one NA in the data set is going to make the whole thing an NA. And sometimes you will have missing values, so maybe you just want to remove that. So let's say X is actually equal to 1, 2, 3, NA. Okay, so you can see that changed on the top right again. So now when we take the median of X, it's going to be NA because there is an NA in there. But if we set NA.remove to true, now we get 2. So it's just taking the median, ignoring that NA value. So most functions are going to have this na.rm as an option here. If you look at the mean function, for example, same idea, right? You can use an na.rm argument in that as well. So let's go back to that C function since, that was a capital C. So it's going to be different. So let's go back to that C function because that's going to be used like all the time. If you're using it to create a numeric vector, that's what we're going to be doing, whenever we make a data set or any kind of matrix or just any list of values, the C is probably going to come up somewhere. And that is interesting, because I did the capital C on accident there and noticed that it gives us a whole different window. So that's good to call to mind that R is case sensitive. So the functions need to be in the correct case. So you can't do like mean with a capital M, right? It doesn't even know what we're talking about. It has to be all lowercase for that, okay? So anyway, let's go back to C. I do have that pulled up. So this combines values into a vector or list. My instructor always told me the C stood for concatenate. I don't know if that's 100% true. This seems to indicate that it's, stands for combine. I always took it as concatenate. It doesn't really make any difference. Objects to be concatenated. There you go. So I guess it could stand for either, really. But the point is that this C is just basically going to group these terms together. It's going to take these terms and turn it into a numeric vector of some sort, okay? So let's go up here instead so that we don't do the list right away. And by the way, so you can do X equals 5 or you can do X with a left arrow 5. These are both fine. Typically we use the left arrow to define a variable, and we use the equal signs inside of the arguments, inside the functions like you see here, but they're really interchangeable. You can use either for either. Okay, so if you see X is set to this numeric vector right now, if we do X left arrow 5 like that, now it's 5. So you can see it works the same way here. So if we use this C function, this concatenate combine function, then this is how we can list out all of the values that we have. So this is, perfect because, we're working with data all the time. So this is where we list out all of our data values, right? So I just made these up, something like this, right? And you can, we'll go ahead and run that. So now we'll see that X is stored as that set of data values. If we run X, now it comes up as that set of data values. So now we can do some stats with it, right? We'll do mean, we'll do median, we'll do standard deviation. That's just going to be SD. And you kind of just will learn the functions as you go. That's common enough to where you can probably just do a quick Google search if you don't know what the function is, but it's probably going to be whatever you expect it to be. And if you start typing it, it'll probably help you out a little bit. Like you see, I did SD here, and what pops up here is it's telling me what kind of arguments it'll take. If we do question, like let's say we do like T dot tests, and it's kind of trying to guess what we're looking for here. So these different t-test functions, or Wilcox, don't have to go that far for this one. And then you can see it's Wilcox.test, for example, for the Wilcoxon test. So they generally follow the same format. So as you kind of get used to it, it'll probably be pretty easy to figure out what the function is called that you're looking for. Okay, but let's go ahead and run these functions here. So if you just run at the end of the thing, like at the end of the line, it'll just run that line. So you want to highlight all of them to run them all at the same time there. Okay, so anyway, you can see mean 36, median 40, standard deviation 22.14. Okay, so this is probably by far the biggest basic thing to kind of have down, is just how to create a variable, how to create a vector, so that you can input your data values, and then how to use the basics of a function. And you're not going to remember how to use every single function, every single argument for them. That's why the help window is here, right? So for like t-test, there's a lot of options on t-test. I don't remember them all off the top of my head, right? You can also, by the way, instead of pressing run, you can press control and enter at the same time, and that'll enter it as well. That'll run it as well, I should say. So like t-test, there's a lot of different arguments, and the ... at the end of these, this indicates that there's even more. It's just not listing them all, because they're probably not common, but there are some like hidden things inside of here that you can do, and it lists out some of them, like na.action, for example. That's not listed out up here, but you can see that that is something you can put in there. So these are just the most common ones here. So you have your x, which is typically is going to be your numeric vector. You can have a second one. By default, if you don't put a second one, it's just going to ignore it. That's what the null means. Alternative, so whether you're doing a two-sided test, a less or greater than test, if you're doing a one-sided test. By default, you're indicating that the true value of the mean is 0. If you want to do a paired test, if you're assuming the variance is equal, what the confidence level is. All right. So there's a lot of options here is the point. You're not going to remember them all. You don't have to write them out every time if you put them in order, but if you don't write what they are, it'll assume that they're in order. So like if we put X in here, for example, and then let's say that the next thing we put is less, it's not going to have any idea what we're talking about, because now it's thinking that, or I shouldn't have the question mark there. Now it's thinking that less is going in for Y because it's going to take it in order. But if you specify that alternative is equal to less, and less needs to be in quotes here, that's what it's indicating. That's why it's in quotes in the help window here. Then it's going to know what you're talking about. It's going to put it with the alternative part. Okay, so it'll take them in order if you don't specify which argument you're talking about, but you don't have to put in something for every argument if you do, name it like that. Okay. So some other important things just in the files here, import data set, that's going to be huge because you're going to import data all the time. It's pretty self-explanatory what to do here. But it's either going to be usually a text file or an Excel file. I would say most of the time it's probably going to be an Excel file. You do need a package for this typically, which may or may not already be installed, but here you go. If it's not installed, it'll ask you to install them. So you see it needs the read Excel package and RCPP package, right? So I'm gonna let it go ahead and do that. I should already have them installed. I might just need to update them. And then once you do that, I mean, it's just gonna basically ask you to pull up a file. So I just grabbed this file, which was from, the 200 class, undergrad class data in daily life. It's just looking at just we were just making line graphs with this. So just generally looking at measles cases for each age versus number of, the 2-year-olds that are immunized and by year. So pretty standard data set. So you can see here, all I did was click on the file, so I didn't really need to do anything here. You can see what it's doing down here is it's entering the code. So you could do this manually. You don't have to go to the import section. This is just easier because it's filling in the code for you. So you can see by default, it's going to name this variable, which is going to be stored as like a matrix or a data set. It's going to store it as England underscore MMR. So that's fine. I'm fine with that. You can change it to whatever you want. And then it's going to use the view function with a capital V this time. That's going to pull up the data set. So let me just get rid of, or it won't let me get rid of that. Oh, that's fine. We'll just let it do that. And then I'll show what that means. And see what's clicked here is the first row as name. So the first row is going to be the name of the column. That's good. That's how it is structured. It's not always going to be structured like that, so you can unclick that if you don't want it. Sometimes you have different sheets and multiple sheets on the data set, so you can specify the sheet here. You can see in the code, it'll just name it as sheet 1 or whatever. So yeah, so I think that's good. So we'll go ahead and import that. So, so if I just type in England MMR, which is now stored as a data set over here, you can see it'll pull the whole thing up. It doesn't look very nice in this window. So instead we're going to use that view function. And again, it's case sensitive. So I got to capitalize that E. And then it's going to pull, when we run that code, it'll pull it up as its own tab over here. And it actually is its own tab. You can take this out and I got to do it outside the window, which I can't really do on the recording thing, but you can take this out outside of your window and it'll open up a separate RStudio file with just that data set, which is kind of helpful if like you need to have multiple pulled up at the same time. Okay. So yeah. So this is really important because we're going to import data sets all the time. Normally you're going to be working with a data set, so you're going to need to import it, of course. You're not going to type them all in manually. The next problem we look at, we will type it in manually, but generally you're going to have an imported data set like this. So yeah, so I mean, you can just go find, some Excel file you already have and just kind of try to play around with it. You can try to like pick out parts of it. So all you have to do is like, you can use the brackets next to it and then specify like rows and columns. So if you just want the first row with all of the columns, or let's say we want the first row, second column value, go ahead and type that and we get 91.5, which we can see is right there. If we want, just copy that. The first row with all of the columns, we just leave the column part blank, but we still need that comma there. Okay. So you can see that gave us the first row. So you can kind of play around with it, try to pick out pieces of it. You know, if you try to do something like mean of, you know, that first column, it's not going, it shouldn't work because, or that first row, probably make more sense to do it for, let's say, like the second column. It's not going to do anything because it doesn't think that these are numeric values, because we never said that they were numeric values, and just because it's numbers, it's not going to automatically assume that. So you have to change them to numeric values. So the way you do that is as dot numeric. So you're telling this thing to function as a numeric value. And then it still doesn't work. So, I mean, this will happen a lot, just getting a error message. Or this one didn't give us an error. This gave us, the first one didn't give us an error. That gave us a warning because they were just NA values. This one is saying you can't do that at all because of the type. So that's because it's a list object. So we can use this double bracket to get around that. But you know, at this point, we're getting a little bit too technical, but you know, we can go ahead and just show that for now. You know, these are things that might not come up for a little while anyway, but good to see them now, I guess. So yeah, you can just play around with it. You know, you'll get errors, but that's fine. I mean, half of the, you know, fun of programming is troubleshooting those errors and trying to figure out why you're getting the error and getting it to do what you want. And you'll get less of those as you know, kind of get used to things. So, and it'll of course give you a message, kind of trying to give you a hint as to what's wrong with it. But yeah, so just play around with the data set. And then in the next video, we're going to look at a problem that, you know, we can actually use some of these things for. And I'll go over them kind of again as we look at the real context.